So example number 3 out of your textbook, we're given the function f of x is equal to the square root of 1 minus x squared. And we're going to apply the mean value theorem, but they also tell us a couple things. They said that a is -1 comma f of -1, and that b, big B, capital B,
Big B.
I shouldn't have said it, is 1 comma f of 1. And it says find the tangent of f on the interval -1 comma 1. Okay. That's parallel to the secant AB. All right. So let's graph this. I don't know if you guys recognize what this is, but this is like a circle. It's like half of a circle, right? So if we come in here, bless you. If we come in here and let's graph the original function, I got to clear out some graphs here. So if I come in and I say the square root of 1 minus x squared, was it? And let's graph it. So it's like the top half of a circle. Now the equation of a circle, x squared minus y squared equals 1. That would be a circle with a radius of 1 about the origin. If I solve for y, I'd get this equation. So that's how Mr. Adams recognized it, okay? And so what we're looking at is we want 1 and -1. Now I'm going to do the algebra in a second. But when x equals 1 or -1, in other words, if I hit trace and I enter in -1, y equals 0, right? And so then the other thing is, if I hit 1, when x equals 1, y equals 0. So really what we're doing here is we're going to plot the secant line from here to here. All right? And what we're looking for by using the mean value theorem, and so let's label this. I'm going to label it right on here. So we've got, this is A, and this is B. And according to the mean value theorem, somewhere on this thing there exists a C. So somewhere in between here, there's a C where the tangent line is parallel to that secant line. Now, I mean, if you look at it, you can tell that C equals 0, right?
Yeah.
I drew it a little bit over to the right because I wanted you to think that it could be anywhere between A and B. So remember now, according to the mean value theorem, there exists f prime of C that's equal to f of B minus f of A all over B minus A. Now, informally, this right here is just the slope of the secant line. So and you got everything I'm writing down, you should be writing down as best you can. Slope of secant. I misspelled secant, so don't write that down. Secant. Okay, and that's from capital A to capital B, which would be like, I guess.
Big B. Big B.
Yeah, I didn't say big B, I said capital A. So that's capital A and capital B, right? So little a, little b is talking about the x values, right? Capital A, capital B.
Big B.
is the secant line, right? It's actually a line segment. And so how do we use this mean value theorem? Now this just states that this exists. All right? That just states that this exists so long as what? If
It's
f
continuous.
is what?
Continuous.
Continuous and what else? Or what else?
No cuts.
No buts, no
No,
buts.
that's right, no cost per corner, which means it's
No cuts.
Oh, no cuts.
Differentiable.
Not no cuts.
differentiable, if it is differentiable. Okay?
Brown.
On A comma B. All right, and so that's the challenge that we have here. And so this is technically A comma B, right?
Yeah.
And then we can think of this as like a comma f of a, and this is like little b comma f of little b, and this is capital B. So anyways, how do we do that? Well, first of all, is it continuous?
Yep.
Yeah, between 1 and -1 it's continuous, right? Notice very carefully, it's very subtle, but Mr. Adams did not use the inclusive brackets, I used parentheses. Because if I plug in 1 or -1, well actually it'll work, right? Because 0 is a number,
Yeah.
yeah, but I can't go outside of 1 and -1, okay? So it's continuous, and differentiable, right? We know that because we looked at the graph. So the only other thing is to see if f prime doesn't exist. Right, that would be, oh no wait, I'm thinking of extreme values. So now we just need to take the derivative of this. So we're going to say that before I take the derivative, I'm going to clean this up a little bit. I'm going to say 1 minus x squared raised to the 1/2, because that'll be a little easier for me, right? It'll be a little easier for me to take the derivative of that. So what I'm going to do, to take the derivative, we're just going to use the power rule. So I'm going to take 1/2 and toss it to the front, and then the stuff on the inside remains the same. Then I subtract 1, and yesterday I made a mistake and nobody caught it. But what's 1/2 minus 1?
-3/2.
No,
-1/2.
-1/2. That's the mistake I made yesterday, but that's okay, it worked out. And then what else do I have to do?
And you
Gotta do the chain rule.
Inside.
So I gotta tack on the derivative of the stuff on the inside, which is the same. I'm gonna toss the 2 to the front and then subtract 1. So this becomes -2x, right?
Yes.
Alright, now this 2 cancels with this 2, and that's about it. Now, well, I know what it is in my head, but sometimes when I skip the answer, like sometimes when I skip ahead, you know what I mean? It confuses you guys. So I'm going to write out every step. Thank you for laughing at me, by the way. I feel so much better now. So now I'm going to have an x on the top. So I've got x times the quantity 1 minus x squared raised to the -1/2. I don't like that -1/2.
I thought it's a -x.
Oh yeah, it's a negative. We can't forget the negative sign. See, good job. Cut the mistake. All right. So now I don't like this negative thing, so I could put that on the bottom, right? So I could say -x all over 1 minus x squared raised to the +1/2, which is really just -x all over the square root of 1 minus x squared. Is that right?
Yes.
All right. All right, so now what?
Plug and chug the mean value theorem.
Well, this has to equal something, right? So now that we found that, the next thing that we have to do is we have to remember what the mean value theorem is. The mean value theorem says that f prime of c should be equal to f of b minus f of a all over b minus a. And you say, well, Mr. Adams, that was so long ago. What were those? Well, here are the points, right? What point is this? What point is a? What point is that?
-1, 0.
Yeah. So our points are going to be -1, 0, and what was the other point?
1.
1, 0. So we got to calculate the slope. Now, what should it be based on the way the graph looks, right? What should the slope of that little blue secant line segment be? 0. Am I going too fast?
No.
Okay. So remember, this is a, comma, f of a. This is b, comma, f of little b. All right. So I've got to solve what this is. So if I do that, God bless you. We say that f prime of c should be equal to, and let me slide this up so we can get all of our information in. F of b, which is 0, minus f of a, which is 0, all over b, which is minus what is
Negative
negative 1. Minus 1. So then 0 minus 0 is
Zero.
all over,
2.
which is,
0.
so what are we looking for?
Nothing.
Technically, you're correct.
Woo!
We're looking when f prime of c is equal to nothing or 0. But what did we say f prime was?
At negative x over.
Yeah. So the next thing, do you guys remember all this? So that means that negative x all over the square root of 1 minus x squared has to equal 0, right? Because this is f prime. And then remember, can somebody tell me in regular English what that 0 represents? Slope of what?
Of the
Tangent.
tangent.
Of the secant.
Ah.
And f prime represents the slope of the tangent.
Yes. Whoa.
So the mean value theorem,
The real MVT.
the real MVT, what we're trying to do is we're trying to find the slope of the tangent line such that it's parallel to the slope of the secant line.
Okay.
Does that make sense?
Yes.
That was funny.
Yes.
Okay.
Do you have a question?
No,
You look like you were
you're just
pondering
like-
something.
It's like SOTLLSOS.
That's parallel.
I know.
Soft parallel sauce.
Sato sauce. Okay.
Soddle.
Whatever helps you remember it.
Soddle.
The real MVP is so
Alright.
soft.
You guys are having too much fun in calculus. So we're not done. Now, to solve this, there's a couple of ways you could do it. But we all kind of agree that in order for this whole thing to equal 0, the top x, negative x, has to equal 0, right?
Right.
Whatever number we get on the bottom doesn't matter. If we can make the top equal 0, then that's okay.
No, it's all good.
Now, clearly there's some extra things we could do to find all the solutions for this, but we're just going to pick the one that's trapped between negative 1 and 1. And 0 is between them. Does that make sense?
Yep.
So we're going to say that this is true when x equals 0. That's it, we're done.
Yay.
Are we?
No.
No.
No,
What do we have to do?
we have to find the line, right?
Slope.
We just did find the slope.
Yeah. You know what Mr. Adams did though? And this confused some people yesterday. Technically, the way that we're supposed to write this, instead of this x business, we're supposed to say minus c over 1 minus c squared equals 0, right? And if we did it that way, then our answer would be c equals 0. Now, why do we use c instead of x?
Because x is in the tangent and then c and a is in the mean value theorem. I made that up.
It's because 0 is
Did you?
the. Wait, no. I don't know.
Spitting words.
Now, how do I figure out the slope of the tangent line though? Because we're not quite done. Because that's what we need to do. Is we need that was the slope,
So
and this occurs when what? But how do I verify? I guess is what I'm trying to say.
graph it.
Kind of. All right. So all this information that I put here, all right, all that stuff that I put there. What am I trying to say? Can somebody tell me what I'm saying? C equals 0. Okay, that's great.
You're saying that the line secant to that the slope is 0.
Parallel.
Okay, so we have a secant line from here to here, like that.
Yeah.
And I want to know what the slope of the tangent line is at a particular x value.
Yeah.
It's 0.
But
And we're saying it's 0, so how can I verify
because
Okay.
saddle sauce.
that? That's true. I'm gonna zoom in a little bit so we can see it a little more clearly. I'm gonna say negative 1 to I want to say negative 2 to 2, and then for the y's I'm gonna go negative 1
CPCTs.
to 2. All right. So I'm going to zoom in on my graph a little bit, and I'm going to have to change this. So what we're trying to determine is we have the secant line, capital A to B.
Big, big.
And we're saying that the little c, when c equals 0, the slope of the tangent line here, or dy dx, right, because that's the slope of the tangent line, what should it equal?
Yeah.
It should equal the slope of the secant line. So the slope of the secant line, whoops, wrote right off the page, of the secant, right,
0.
and then maybe I'll change this to a different color. So this is dy dx, right, and remember that represents the slope of the tangent. Now, if there's just some way on my calculator that I could verify dy dx.
Huh.
Huh. Oh, actually there is. So if I hit second trace, dy dx, do you guys see it?
Number 6.
Number 6.
Nope.
And then I'm going to enter in 0 for x.
0.
What is dy dx?
0.
0.
Whoa.
See? Just had to grab it.
Subtle sauce.
Subtle sauce.
Is that Loki Tao's assistant?
Now it says find a tangent. Have we found the tangent line?
Yes.
Okay.
We found the slope, but what is this point right here?
1, 1. 1, 0. 1, wait.
0,
0,
1.
1.
0, 1.
I'm sorry.
Oh my goodness. So we're almost done.
Gotta plug and chug.
So we said, all right, so we need to write the tangent line. So to write the tangent line, the equation of the tangent line, we said that dy dx was the slope of the tangent line, which was equal to 0. If I had a point like 0, 1,
We do have.
I could plug that into y equals m times the quantity x minus x sub 1 plus y sub 1. Right?
Yeah.
So that's the point slope form, but Mr. Adams takes that y and just adds it to both sides, and that's what we end up with. So what I have here is I have y is equal to 0 times x minus x sub 1, right? Because this is x sub 1 and this is y sub 1. And so I've got minus 0 plus 1, or y equals 1. I'm recording. All right? So y equals 1, right?
Yes.
Yay!
Is that the tangent line?
Yeah.
Yeah!
How do I verify that?
Graph it!
Graph it. So I'm going to come in here and I'm going to say
What?
y equals
1.
1 and hit graph.
Oh my god.
Look at that!
Woo!
All right. You're welcome.
I'm really hyper. I think it's the